The landscape of artificial intelligence is shifting beneath our feet. We are moving away from simple chatbots that wait for a prompt and toward autonomous agents that act on their own. These agents are designed to browse the web, execute code, and manage complex workflows without constant human intervention. This capability is transformative for productivity, but it introduces a profound security risk that most organizations are just beginning to understand. We are talking about data exfiltration through agentic workflows. When an AI agent is given permission to access your tools, it can inadvertently leak sensitive information. This is not a matter of a hacker breaking in. It is a matter of the system itself handing over keys to the vault because it was not trained to keep them locked. Here is the thing. Traditional security measures are designed for static systems. They look for suspicious network traffic or unauthorized login attempts. But an AI agent is authorized to move data. It is authorized to access APIs. It is authorized to make requests. If the agent decides, based on its internal logic, that it needs a customer's email address to complete a task, it will fetch that email. It might even send it to a third-party tool it thinks is helpful. This behavior violates the principle of data minimization, which states that systems should only access the absolute minimum data required to complete a specific task. Research into this area suggests that current agents often fail this test. They tend to hoard context and share more information than necessary during complex interactions. To understand the scale of this problem, we have to look at the benchmarks being developed to measure it. One significant study introduced a benchmark called AgentDAM. This tool evaluates the privacy leakage of autonomous web agents. The results were stark. Agents based on advanced models like GPT-4, Llama 3, and Claude frequently fail to adhere to data minimization principles. They use sensitive personal information when it is not strictly necessary. This is a more realistic assessment than simply probing the large language model directly because it tests the agent in a real-world scenario where it is interacting with external tools. The agent is not just talking, it is doing, and in doing, it is leaking. This brings us to the concept of trust, risk, and security management, often abbreviated as TRiSM. For agentic AI, this framework is becoming essential. You cannot secure what you cannot see. Visibility into AI agents is a foundational requirement for effective auditing, yet it remains a significant challenge in current systems. If you do not know what an agent is doing, how can you stop it from sharing data? The emerging consensus is that we need to audit the workflows themselves, not just the underlying model. We need to look at how tools are orchestrated. When an agent calls a database, does it pass the right parameters? Does it sanitize the input? Does it restrict the output? Consider the workflow as a series of handoffs between different digital workers. If you are managing a team of contractors, you do not give every contractor the master key to every room. You give them the tools they need for their specific job. AI agents are currently being treated like they need access to everything, and that is a vulnerability. When we talk about auditing modern agentic workflows, we are talking about inspecting these handoffs. We are looking for moments where the agent might be forwarding data to a tool that does not need it. We are checking if the agent is storing data in logs where it should not be. We are verifying that the permissions granted to the agent match the task at hand. Now consider the mitigation strategies. Some researchers propose prompting-based defenses. You can instruct the agent to be careful. But relying solely on instructions is like telling a human employee to be careful with the company's secrets while leaving the filing cabinet unlocked. It helps, but it is not a robust solution. The research indicates that further work is required to develop AI agents that can proactively prioritize data minimization. This means the agent itself should be designed to ask, do I really need this piece of information, or can I complete the task without it? Until that capability becomes standard, we must rely on external auditing. So, how do you begin to audit these systems in practice? You start by mapping the tool orchestration. List every tool the agent can access. Define the data flow for each tool. Then, you simulate tasks to see what data is actually exchanged. You look for patterns where the agent retrieves more fields from a database than the task requires. You check if the agent is inadvertently including credentials in its output. This is a manual, labor-intensive process, but it is the only way to gain true visibility. It requires you to treat the agent not as a magic black box, but as a system with inputs and outputs that must be validated. There is a broader implication here as well. The current landscape lacks comprehensive auditing standards. We are seeing a call for the establishment of AI audit standards boards to standardize security practices. Without these standards, every organization is reinventing the wheel, and every organization is likely to miss a critical vulnerability. The increasing scale of AI security problems, estimated to involve billions of data points, underscores the urgent need for actionable mitigation strategies. We need to move from reactive patching to proactive design. We need to build agents that are secure by default, not secure by hope. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.